everybody. This is the notes for geometry week 2. We're going to be doing segment addition postulate and angle addition postulate. I'm just going to do this first video here for the segment addition postulate. I'll make a separate one for the angle addition, but they're really the same idea. So with the segment addition postulate, we have point B that is between points A and C, and that word between is a little bit specific. It means point B, A, and C are all collinear, so they're on the same line. So the idea here of segment addition postulate, we're going to take segment AB, we are going to add it to segment BC to get the whole thing. And that's our setup. So we're going to take segment AB, x plus 4. We're going to add that to segment BC, which is the 9x minus 11. When you add those two things up, you get the whole segment AC, which is our 43. Now the algebra to solve it, we're going to combine our like terms. So x plus 9x, 10x. Our constant's 4 minus 11 is a minus 7, and that equals our 43. We're trying to get to 10x by itself, so we're going to add 7 to both sides. We get 50, that's a 0, to equal our 10x. To get x by itself, we're going to divide by 10 on both sides, and we get x equals 5. Now, that's part of the question. It says solve for x. Okay, great. Did that. The other part of the question is, what's the length of BC? So BC was our 9x minus 11. 9 times x. We found x was 5 minus 11. So now order of operations, 9 times 5 is 45. Minus 11 is 34. There's our length of BC. And that's it for that one. This one, same setup. The algebra is a little bit more. So the idea of the setup here, segment AB is our x squared minus 6x. We are going to add that to segment BC, 2x plus 1 to equal the whole thing, 22. Okay, we're still going to combine our like terms like last time. Now, x squared is just by itself. Minus 6x plus 2x is a minus 4x. Plus our 1 to equal 22. When we have, this is called a quadratic, but when we have the different powers of x, we got x squared, we got x to the first power. In order to solve for x, what we need to do is set this whole thing equal to 0. So I'm going to minus the 22 from both sides. So we get our x squared, minus 4x. 1 minus 22 is a minus 21 to equal 0. That equals 0 is a key part of this. Our next move, again, because we have different powers of x, we're going to factor. Now, your teacher may have explained factoring in a different way, and you can ask them how you factored if you're struggling, which is fine. But the way I think about it is doing FOIL in reverse. If we knew what was in this parenthesis and we knew what was in this parenthesis, we would FOIL, first, outside, inside, last, to get to this. So I'm going to use that as a guideline. Our first terms always multiply to be our first term. So two things to multiply to get x squared, x and x. Our last two numbers that go here and here multiply to be our last term. So we've got to find two numbers that multiply to be a negative 21. There's only a couple of options. But the right ones, when we add our outside and our inside, we have to combine those to get our middle term of negative 4x. So multiply to be negative 21, I'm going to go minus 7 and plus 3. Again, if you do the outside of FOIL, 3 times x, and the inside of FOIL is negative 7x. When you combine those two like terms, there's our middle term. Now, we are multiplying x minus 7 times x plus 3 and getting an answer of 0. So that means either x minus 7 equals 0 or x plus 3 equals 0. And we're going to solve each one of these. So for x minus 7 equals 0, just add 7 to both sides. X equals 7. For x plus 3 equals 0, we're going to subtract 3 from both sides. X equals negative 3. Okay, so right now we have two possible answers. X equals 7, x equals negative 3. But we got to go back up to the problem. When we plug in those values of x into segment AB or into segment BC, segment lengths have to be positive. This negative 3 is catching my eye. If I plug in negative 3 in for x up here in segment BC, what we're getting is 2 times negative 3 plus 1. 2 times negative 3 is negative 6 plus 1. That means segment BC is a negative 5. That can't happen. So x equals negative 3 is not a good answer for our situation. If we do x equals 7 into our two segments, it's fine. So x equals 7 is our one and only answer. That's the segment addition postulate. Thanks.